Okay, so welcome back to another video. In today's video we have a definite integral from 0 to 1 of x to the power 1 over ln of x dx. And of course, from anybody looking at this, you might be thinking this is probably impossible to integrate. You could try u-substitution, that's not going to do you any good. You could try integration by parts, that's also not going to do you any good. Well, it's probably possible that you might get somewhere, but probably the work behind it is very, very tedious. So you don't really want to continue further with that progress if it doesn't get you anywhere. However, even though this may seem like an impossible integral, this is actually really easy to integrate, and you'll see why. Well, I mentioned earlier you couldn't use u-substitution, but you wouldn't use u-substitution from the obvious way. We would actually have to use a different function of u-substitution to make things a little bit easier to manipulate the integrand. And it's not only just that. It's not just one method. There's actually also a second method in integrating this integrand. So that's what I'm going to do. Two solutions on integrating this impossible-looking integral. So we'll jump right into it. Okay, so the way we to start off is, of course, as I mentioned, u-substitution. You don't want to use the obvious. When you're looking at ln of x, you might think, let's substitute that for u and then perform the differentiation with both sides and putting the pieces together, but it's not really going to do you any justice. So really what we can do is applying this the indirect substitution. We say that x is equal to e to the power u, all right? And if we differentiate both sides, then we would get that eu du is equal to dx. But of course you want to substitute u in terms of from the x. So we have to say that let's see, we just so okay, we take the natural log of both sides, so we have ln of x is equal to u. All right, now we plug in our new integral. So when we plug 0 for x, we would see that with u, it's actually approaching with negative infinity. And then when we plug 1 equals x, then u would have to be 0. Let's see, we plug our x where we said x was equal to e to the u. Yeah, with our exponent 1 over u, and then multiply with our dx substitution, which is this e to the u du. Okay. And then you'll see that if we just use the distributive with the exponents, this is just cancel out to just e. So we have 0, negative infinity of just e, and then multiply with e to the u du. E is just a constant, so I can just write this as e and then multiply with our integral, and then it's just e to the u du. But then you can see that this is just it's just e and then times e to the u itself. So we integrate this from 0 to negative infinity. Plug 0, you get that that's just 1. You plug negative infinity, the whole thing just becomes 0. So therefore, you're just left with this definite integral is just equal to e. All right. So that's one way down. So let's see, that's our answer. So that's one way. So now let's actually use the other method. Okay, so now the second method, what we can do is that if we let some, if we consider the change of base formula for the logarithms, if we say log of a and then b, and so if you were to solve this, so let's say we set this equal to x, then let's see, we know that by definition it's actually just a to the power x is equal to b. Then if you try to solve for x on its own, then let's see, we take the natural log of both sides, so ln of a equals ln of b, and so that means x is equal to ln of b divided by ln of a. So we use this formula over here. So now let's actually consider that if we consider ln of x, then really you can write this in terms of logs. So this is actually just equivalent to the log base of x, and then that's divided by the log base of x and then e. And then we know that the log base x of an x, that's just equal to 1. So it's just 1 divided by log base x and then e. So if we substitute this back into our integral, so let's see, 0, 1, x, and then 1 divided by log x e dx, of course. And then simply, let's just flip the reciprocal, so we're just left with x to the power log x e and then dx. But this is easy to show that x and then with the log base of x that just cancel each other out, and then there's just e as the new constant. So we have that this is just the integral from 0 to 1 of e dx, and then solving this indefinite integral is just a constant, but it's just integrate that, it's just you have a x multiplied with that constant. So it's x to the e divided by r from our bounds from 0 to 1. And so you just plug 1, it's just e, you plug 0, 0, so therefore you get that this is just equal to e. And it's simple as that. We we verify in two different methods. It's actually easy to show, and it's not that impossible than you think it is, just like that. So yeah, that's pretty cool if you ask me.